as we get started, hello, hi. We are going to try to do as much of the notes today as we can because I just started it. Yeah. What am I trying to say? I'm going to try to do, we're going to finish 9.3, hello. And then we're going to attempt to do as much of 9.4 as I can because as you may be able to see, this is pretty small. But next class, so on Monday, I'm just going to finish 9.4 and then the rest of the time is going to be for you guys to work on your problem sets. So I'd like to get as far as I can into 9.4 so that you guys have as much time as possible to work next time. Before we get started, though, I kind of just wanted to do a little bit of a share out, I guess. So I'm going to give you about 3 minutes. And then we're going to have everyone stand up and you have to share something that you have learned in Unit 9. So just anything, can be big, can be small, but anything about Taylor series, interval of convergence, power series, stuff we've been doing. I'm going to give you about 3 minutes so you have a few ideas because every table is going to share something different. So I'd have a couple of ideas. You have 3 minutes to find something to share.
This Pepsi, I got mine. She wants to go first. Or we want to go first.
What? Is this Unit 9, Cheryl?
Trying to appear to be a good teacher today, you know? Oh, attendance. That's what a good teacher does. Is Austin just gone?
He's here.
He's here?
I saw him, yeah. He was walking to the cafeteria as I was leaving.
Probably a microwave.
Why wouldn't he do that at the beginning of
He
one?
did that before, you remember that? Came in late to the microwave in his hot pocket and he instantly dropped on the ground. That was like the funniest thing. I don't even remember that. That was ages ago.
Alright, Annika's not here. A lot of weird things happen to me. Like I found this.
What?
Blow it up?
Yeah.
His desk actually has weird stuff.
Yeah.
I love it.
So much. You wouldn't dare.
You wouldn't dare.
You wouldn't dare.
This FDR is so good.
Yours is so good. I'm gonna be really impressed. And impressed enough to let you sit back down. Wow. All right. Does everyone have a few ideas? You still have 45 more seconds. I'm gonna record some of our ideas. So I'm gonna get ready. All right. Gotta sit down and be ready for these good ideas. Are you writing Taylor series on your hand? It's a pretty impressive formula. So, just so tired. Everyone stand up.
Can we go first? No, we can go. Anyone wants to go?
If anyone can guess the number in my head, you can go first.
10, 4, 7, 11, 13,
2, 3, 4, 5, 6, 7,
3 is technically closest. You said 3. All right, you guys first. Everyone say hi, Miss Inman. All right, front table. Impress me.
Oh, I'll go. Okay. So
Oh, okay. What do you mean repeating?
Not repeating, like the formula, you just add the same thing.
Okay, why'd you say after the square? So same formula. Tell me something about that formula. There is something that appears after the squared term or at the squared term.
You start using the
factorial sign.
All right, so
She means like
start the factorial
just in like how it's always
at the
like, do
squared.
2 factorial, 3 factorial.
Yes. All right. Cool. You guys can sit down. Who wants to go next? Izzy. Sorry, your email is in my brain. Liza.
The only difference between a series is the center is always 0.
Nice. You looked at the meme. Center is. Oh, that's why the meme is funny. Can I copy your homework but not make it obvious and name it after myself? All right, you guys can sit down. Thank you for sharing. Nicole.
Starting the second derivative, you put the factorial of n in the denominator.
What?
So
We already did that. We already did that one. That's here. I'll come back to you guys. Mason, impress me. Oh, okay. So sine of x, I'm going to rephrase that, only has odd stuff. All right, cool. You guys can sit down. Cora. All right, this is my general term. Cool, you guys can sit. All right, Zach. Sorry, you guys next. Too long. James.
Okay, so for interval convergence,
Whoa.
you have to perform ratio tests.
Oh, interval of convergence, we do ratio test. That's a nice one. I like that. All right, Jess.
For Taylor's series, if it says degree, that's the power, the largest power.
Nice. Our degree is our largest. That's not how you spell largest. Largest power. Nice. Sitting. Oh, okay. So approximating worse farther from center. Bathroom? Yeah. Yes. All right, so our center is usually given, and we usually plug that in to find a lot of our constants. Nice. What? Yeah, it is kind of our most important point. All right, tell me something related to Mason's. He said that sine only has the odd stuff. Who has the even stuff? Lily. Cosine. All right, Cora gave us the general term, but if we're thinking odds, evens, what does E have? That was all of it. Sorry, that was a vague question. I wanted a specific answer. What does E have? Any other things that you guys think are important that we could share? All right, we got a lot of stuff covered. All right, while you find your 9.3 notes, because we're going to go back to those. They say Taylor series on the top. Yeah. I would like, Michael has requested that we actually do the number talk. So I have this here. This is a bowl full of coins. I want to know how much it weighs. I will tell you the unit is pounds. I don't know. It's probably like a normal like Pyrex bowl would be my guess. All right, who would like to own a number? Connor? Oh, Connor has a clarifying. I don't know.
Is it a decimal number?
It's zeroed out right now, so I'm counting the bowl.
Yeah, because they're not weighing it.
Okay. Lily, what do you want to own?
13.6 pounds.
Oh, going for the decimal right away. Who else wants to own a number? Sydney. 12 flat. All right. Michael says 18. That's all right. Was that right? Why were 13? I just can't hear. Cool. See, Sean? 11.9. James. 17. James other. 14 and a half. All right. Me, because that's how you said it. I like fractions. 23.8. Ashley. 20 flat. All right, Tally. Okay. Connor. All right. Kian. 9.6. Jess.
17.23.
2 decimal places. Be accurate.
14.8.
Cora. 25 flat. Nick.
16.
Brendan.
14.
Man, 14. Really, really popular. Liza. 10 halves. Pounds. I was like 10 halves. Why wouldn't you just say 5? Anyone else? All right. There's no video reveal.
Oh.
Sorry.
That ain't right.
Are you ready?
Yes.
I'm gonna write it big. Oh.
Wow, so already wrong.
Oh,
So they are counting the whole.
That's what I told you. I thought they were. All right. Who's the closest? I think Cora. Cora. Because I wrote you right on the scale, right? All right. So, now that our fun is over, Taylor series. All right. I promise. So I know I'm going to talk a lot today. I apologize. Hopefully you love the sound of my voice. Sometimes I listen back to the record. Oh, I was trying to figure out with the recording yesterday. I tried to go back because it died right at the end and everyone was like, oh. I tried to see if it got recorded. It did, but it wasn't very loud. But I heard the sound of my voice and it was terrible. Oh, the worst. All right. So if you remember, you guys told me a lot about the elementary power series in our little stand and share out. Remember last time we did find the power series for e to the x, the power series for sine, the power series for cosine. We're trying to right now build off of those so that we don't have to do this stupid process of just taking derivatives until we see a pattern. So what we did at the very end of last class was we took sine of x and then we substituted x squared everywhere there was an x to get a power series for sine of x squared. We, in the kind of notation of this, I said it might be a good idea to write out your power series that you're working with and then do whatever you want to it. So we're going to do the same thing with x times cosine of x here. And then instead of like doing a derivative like we did on the last one, we're going to integrate. That one's going to be kind of annoying, but we're going to deal with it. So just be willing to write a little bit. So cosine of x. You guys told me about it. Tell me about that power series a little bit. It's evens. What does it start with? 1. Perfect. So 1 minus, because they alternate, x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial. I'm kind of following the directions here. They say give the first 4 non-zero terms. So there's my first 4 non-zero ones. How do I space myself between this and the general term?
Plus ...
Okay. And my general terms. Anyone remember what that one looks like for cosine? All right. So we've got our alternator. X to the, how do we do even numbers? 2n would work. And then the factorial on the bottom. You do need those parentheses, factorial. All right. What am I missing? Plus ... Is that important for these? Yeah. We want our series to go on forever, especially because we're claiming these two are equal. We need to make sure that equality is there. All right, so I'm just going to ask what you would like to be able to do. So we're about to find g of x, which is x times cosine of x. What do you kind of want to be able to do? Just multiply everything by x? Wish granted. We're just going to multiply everyone by x. So it's like an infinitely long distribution. We can do that. Remember, these are built for bravery. So let's start easy. What's 1 times x? Brilliant. All right. Will the factorial change in the second term? No, it doesn't have any x's in it. But if I multiply x squared over 2 factorial by x, x to the third. Cool. All right. Lily figured that one out. So someone whose name is not Lily, what do you think about the next term? X to the fifth, still 4 factorial. Cool, cool, cool. Someone not Connor, not Lily. Perfect. All right. We built ourselves up. We're feeling brave. We're feeling good. General term time. Does the alternator change at all? Nope, we're still alternating. Does the factorial on the bottom change at all? No, super boring. All right, the x's change. Thoughts on a new power? All right, I like the idea of +1. We just added another x into the situation, so 2n plus 1, and I'm going to plus ... so I have infinitely many terms. So again, I kind of want you to see none of this is like, the steps aren't hard in and of themselves. It just looks absolutely terrifying. Every single one of you can multiply x's by other x's. You just have to be willing to write. Let's make that a tad harder, because why not? Let's integrate something. Now, I'm going to do this in 2 steps here. You're not going to like the 2 steps. You're going to think it's too much writing. So I'm going to tell you how you can shortcut it, but I want to do it explicitly first. Remember here that we're still going term by term for the polynomials. We are going, we are going to go term by term to integrate the series that we just got. Notice though, this is the last part of our question. This is the last time we're dealing with g of x. So if I'm thinking of like, let's simplify this, heck no. I'm just gonna kind of integrate it and let it be gross looking. We do have the situation where our integrand is in terms of t. So I'm gonna do this step first in terms of t, and then we're gonna plug in the x's. There's kind of a way to shortcut there because it's gonna feel really repetitive. So let's just start after I philosophized for like 3 hours. Yep, time flies when you're doing calculus. All right. Same thing to me. You don't do an integral when you're bored? I have one specific integral I do. It's this one. Yeah, you have to do partial fractions, and then there's arctangent in it. And some natural logs. It's great. What do you guys do for fun? Mason and James sprint really fast. That's not fun for me. All right. Okay, so I'm going to peek back up here. Again, we're building our bravery. We're going to start with the first term. It's real easy. We're going to use t's. So when you answer, try to use t. So imagine we're integrating x, which is now t. What does that look like when I integrate it? All right, we're going to raise the power by 1, so t squared, and I'm going to divide by the new power. Now, I've been keeping most of these x's in the numerator, so I'm going to kind of just keep doing that. You're more than welcome to pull your fractions out front if that makes you happy. Now, I'm going to show you how I'll do the next term. You guys can help me with the term after that. I'm going to keep the factorial just chilling. Like a constant that's just chilling there before. And I'm going to raise my power by 1. So instead of x cubed, which is t cubed, what power would I have? T to the 4th. And I know I have to divide by 4, so I'm just going to throw that 4 down in the denominator. Again, this is the last part of our question. So I could do 4 times 2 factorial, get 8. That'd be cool. But like, why? Simplifying's for dweebs. All right, so help me out with the next one. What's the next one going to look like? All right, t to the 6th. I like that. I don't like 2 factorial. What factorial was there? That was 4. And then what else should join the perfect? 6 from that divide the new power. All right, take a second. Try to write the next one on your paper, and then I'll ask you about it.
Will they always change the variable from like x to t?
So they kind of do that because they want the end result to be in x's. So t is kind of acting like a holder variable because you can't have x in both spots. We'll talk about how you could kind of shortcut it though. James? Technically doesn't matter. This one was coming from the fact that it was t squared and I was dividing by the new power. So dividing by that too, because this guy didn't have a factorial. Theoretically, you're not wrong though, because 2 factorial is 2. Why we're doing what?
Why we're dividing by power?
Because we're integrating. So think of like when I integrate x cubed, I get 1/4 x to the 4th. So that divide by 4 is that 1/4. All right. Tell me about this next term. What power's on the top? What did you put in your denominator? All right. You feeling brave? So brave, ready to do the general term. So the cool part about the general term, hold on. The cool part about the general term is you can do it a couple of ways. You can do it with the calculus we were just doing, or if you're good at pattern making, you can do it that way. Now I like calculus, so I'm going to do it with calculus. Not that any of you are surprised. I'm going to raise the power by 1. So it was x to the 2n plus 1. What should my new power be? 2n plus 2. Oh, we're freezing. I dropped the n, but I can't fix it right now because my computer's. Yeah, I know. You get a new computer and then it's just like, no. The question is, did it freeze? It's already done it once today. Ooh, might not have frozen. Let's not go.
I prefer not to be frozen.
It's frozen. Hate the sound of their own voice.
Yes.
I'm like elected.
There.
There's no self-love in this class.
Did you say unless I'm singing?
Yeah.
Really? Sing us a song. Yeah, we're still recording. Nice.
Yes. I
Sick.
was scream singing Party in the USA in 2015. Brought the next card of light after not.
All right, we're back in business. So what were you guys mad at? Can you tell me what you were mad at? Oh, I dropped my N on the alt. Are you kidding me? All right, I'm gonna try one more time. Otherwise, I might just have to like. I can do it on the board, or like, you guys. I might have to just drop the Google Meet. I think it's asking too much. I know.
He records both days. So you just record it.
Yeah, but if I record this tomorrow and it does the same thing, it's not exactly helpful. That would be nice.
What about like Screencastify or?
I think is that the one with the? I think that has a 5-minute time limit. If that's the one I'm thinking of. Yeah, can I get a paid version? Or can I get one of those cool cameras where you wear the thing and it like follows you around the room?
Do some
Grant writing?
shopping for how much this thing costs and hit me up.
Ooh, nice.
Just have that power.
She has the power. I don't.
But I have like a little more.
If I can explain it instructionally, then Lusher will probably buy.
Exactly, that's what I'm saying. Like a little write up of what it is. And, like,
Exactly. Because my computer's freezing. All right. Third time's the charm, y'all. Oh, wait. Let me close. I'm going to close. Save. No, I just can't click. It's fine. I just want to like get rid of everything that's not necessary. Okay. The end's back. All right. So we said we were raising the power by 1. So what should the new power be? 2n plus 2. Cool. And then I want to divide by that new power. And then what else was chilling in the denominator? 2n quantity factorial plus ... James. Wait, what?
The cosine when you have like just right.
2n plus 1. And why did it go to 2n plus? Of here? because we weren't integrating here. So all we did to change this one from cosine to x times cosine was just multiplied by an x. So we just added 1x to our exponent. Here, we're changing that one and we have to like do our integral. So we have to actually like do stuff to the denominator. Now, oh, because I forgot because of all the technology. Thank you. Yes, Tally's right. We need to have a t here. Now, what technically am I missing? Because I integrated, but what did my integral have on it? Bounds. So technically, I still need to plug in the bounds 0 and x. Now, this is the part that you're going to find a little bit annoying because what is plugging in x going to do? It's just going to change all the t's to x's, right? Now, I'm going to subtract when I plug in the bottom bound. Well, if I plug in the bottom bound, what is every single term going to be equal to? 0. So plugging in these bounds is really just going to change the t's into x's. So let me write that down and I'll talk a little bit about how we could shortcut this. I'm going to write lightly with all of the types of 2's that I have. I just noticed I was doing a bunch of different ones. I think this is the time. Remember when I said there was a kid that like stormed out because I started writing too many different. I think this was the question. I don't know. Anyone heard from Ryan Vinci lately? Uh-oh. It's been a while. I think he might have. He's probably a senior in college now. Oh, no. I write both types of 2's. No. He went to Tech. I think his dad goes to the same gym as me, so I might be able to check on. Yeah, I think Vinci's dad goes there. Probably. Vinci. That was the year I had 3 Ryans in one class. One block of BC. One of them was Elena Wigglesworth's older brother. So they were like, call him Wiggles. I was like, no. You get to be Ryan. All right, so let's talk about this, because is anyone super annoyed that they had to write both of those? I'll raise my hand. I definitely was. So if hooligans. All right, so I will tell you, if you are feeling intelligent enough to skip that step, I'm okay if you go from here to here. Generally, that bottom bound will be 0, because how many things could we actually find the sum of? Yeah, a lot. There were only 2 types of series where we could find the sum. What were they? Telescoping and geometric. Theoretically, those are a lot of different series. So this one, most of the time when we're doing this much work, we're not going to end up with a telescoping or geometric series once we plug in that bottom bound. So they really don't have a lot of choices of like what the bottom bound can be. So as long as you do a mental check, I'm cool if you go from here to here. Okay. You figured it out. Miss Bella.
You were saying that the bottom bound is normally 0?
It's normally 0 because if it were something different, I'd be plugging that bottom bound into infinitely many terms. The idea that we could find out what those infinitely many terms add up to, probably not going to happen.
And then, sorry, I have a
No, you're good.
We don't plug in the bounds for the extra, right? That's just with the plug.
What? Say that again?
Because it says when you skip the step,
Yeah.
like, just can write it without the bound, right?
Yeah, exactly. So if you skip the bottom step, you wouldn't have to have this like vertical line with the bounds at the end. You would just be knowing that you plug in the x, it would work, and your 0 would just do nothing to it. All right. The next questions are kind of cute. So I'm going to do one, then you're going to do one for practice, and then we're going to hit the kind of 2 hardest questions of today, or at least not hardest, longest. So these ones are super cute. Have you ever wanted to do a limit, but you wanted to just be aggressive about how much work you could show, and you just wanted to make it look a little scary? All the time. So I could do this question with L'Hopital, but how boring. Right? It works for L'Hopital, right? Why would it work for L'Hopital? 0 on the top and bottom when I plug in, right? But I now know a function that is infinitely long and equals sine of x. So let's plug in that infinitely long thing. Actually, let's just build this instead. So can you tell me about the Maclaurin series for sine of x? All right, the odds center is 0. What's the first term of that series? If it's odds, what's the first term? X. All right, next term. Nice, thanks, Jess. Next one. Plus or minus? X to the 5th over 5 factorial. Let's just write the first 4 terms. What's the next one? You guys just assumed I knew it? Wow. All right, here I'm not going to work with the general term because I think when I'm finding a limit, my answer should be a number, right? So I don't think I'm going to need to go all the way out to the general term. All right, so thinking of like what happened next to that sine of x, what happened next as I was doing stuff in that limit? I subtracted x, right? So we're going to go and we're going to subtract x from this. What do you think that's going to change? Yeah. The first term is going to go away, right? And I'll just have to start with minus x cubed over 3 factorial. Now, you might be like, why don't I distribute it like we did with the x times cosine of x? That's not really how subtraction works, right? When we subtract something, we only subtract it once. We don't subtract it infinitely many times. All right. That was fun. Yeah. Subtracting x. More exciting. What happened next? Ooh. Sine of x minus x cubed. I feel like I'm full of sound effects today. All right, so the first term, we're going term by term. Negative x cubed over 3 factorial. I'm dividing that by x cubed. Love it. So we're taking away 3 of the x's. I just subtracted this x. That's literally it. All right, so Nicole got the first division. Anyone feeling brave enough for the second term division? Anyone brave enough for the last one? I'm brave enough for the 7 factorial. All right, what's the very last thing that happened in this problem? The limit. All right. What's the thing we do first and always with limits? Plug it in. Perfect. You got the joke. I sang the jingle. Yeah, thank you. It was quiet though because I was in. For Glade plugins, I'll look it up while we're on our break. That's adorable. All right, my plug-in 0 to this. Will it change? No. So I will have negative 1 over, what is 3 factorial? Okay. What will the next term be when I plug in 0? What will the next term be? I know we don't have it written down, but what will the next term be? Probably 0. Probably 0 for the rest of time, right? Because we're going to have x's in them. So that was a really fun way to say that that limit equals negative 1/6. Kind of cool, right? Kind of cute. I think they're kind of cute. Yeah, I can write it down while you guys do the next one. So I want you guys to try this one. I'll show you the work for the L'Hopital one off to the side if you're curious. This one would actually be really annoying for L'Hopital because you'd have to get that x cubed all the way down to a number. So that'd be kind of annoying.
Are you like building up to that?
Yes. So I'm essentially taking the power series I know and going step by step to build up to this thing. Yeah, I think it is. All right, so you guys try the e to the x one. I'm going to do that L'Hopital work off to the side. Let's come back together in like 5. Brandon, are you cool if I don't check for the indeterminate form every time? Oh, this is annoying. Yeah, you have to loop each all 3 times. It's annoying. Just derivative of top and bottom once you establish your 0 over 0.
We'll definitely review that. So many hundred limits in there. This is good.
I know, we're going to go back and review for the AP test, and you guys are going to be like confused because
It's not even so bad.
Oh, I did miss a negative sign. Thank you. Thank you. Here. Good? Thank you. Yeah, I'm posting this on the internet. I'm giving an Algebra 1 quiz. Factoring using Desmos.
How is that a high school?
For most people, it's not, to be fair. Yes. See, you should have just slowed down. Y'all should have just slowed down, and you could have been.
That was an option I had. I was told that.
You thought you were tough? Did you just say that? I don't think so. Is anyone already done? Ah, you guys are so fast today. All right, divided by 2. So this is a half plus, I'm going to simplify a little bit. X over 4. Is that right? Yeah, that's 4.
Oh, right, you're doing, okay. I see what you're doing.
I just figured I was evaluating the limit later. I might as well. X squared over 12. Yeah, that's fair. That's fair.
Oh, you only have to subtract it.
Yeah.
I literally asked you about that. How did I already forget?
There's a lot going on, to be fair.
Why don't you have to do the
So I'm kind of banking on the fact that I think plugging in 0 is probably going to make me not need that many terms. So I'm kind of just banking on the fact that I think I'm only going to probably need 4. I could add more terms, but I'm trying to go a little over. Your entire table, what's up?
Yeah.
What? How did I divide by 2? You could also write that. What? I'm dividing by an X. Got good? There's a lot happening. Good? All right. So let's talk this out. Are we ready? You don't sound ready. All right. So I took my e to the x. Again, I'm taking the first 4 terms because I think that's going to be enough. I could write more. I could write less. I usually go with 4 just because, like, I know when I'm subtracting 1, I'm losing 1 already. So I'm trying to make it so I don't have to go back and add more terms. I definitely don't need the general term because that's too far into the future. We're gonna be plugging in stuff in a second, so we're feeling good. We're feeling great. Subtracting 1 just gets rid of that first term there. When I subtract, I do it once. When I divide, though, think of like distributing. Now, dividing by the 2, you can either leave it unsimplified like the blue, or you can simplify it. I just did. I don't know why I felt like simplifying, so I just did. Dividing by the x essentially gets rid of one of the x's. So x divided by x is 1, x squared divided by x, x cubed divided by x squared. Then plugging in my 0 for the direct substitution on the limit, I'm getting 1/2 because everyone dies except the first term.
For my on my notes.
Yeah.
Like what we did last class.
Yeah.
For the for EDX, I have 1 plus x squared. X squared.
If we erase that first squared that you just said, just x. Yep. All right. I'm feeling like I want to take a break a little early, but after this next question, can we do one more? Yeah. All right. So I really like these last questions, and one of them has been on the free response relatively recently. It is a big question, but again, if you're willing to write, none of these questions are horrific. You're probably not going to like this one very much. I like it a lot, so let my enthusiasm roll through you. Yeah.
How many series will we be expecting?
3.
Yeah.
4. I lied. 4. We're going to add one more today, but you already know it. No. You will. What? Yeah, we're not going to memorize that one, though. All right. So what we're going to try to do is we're going to try to multiply 2 series together. Now, the directions are a little bit different in this one. A very, very vague question. Do you notice anything different about directions? What they're asking you for? They're specifically asking us for 3 terms. That's because if I multiply 2 series together, I have infinitely many terms times infinitely many terms. That's like infinity foil, essentially. So we're not going to do all of that. We're just going to try to make sure we get 3 terms going. So let's write down what e to the x is. Do you guys know what it is yet? Have you memorized it yet?
1 plus x squared over 2 factorial plus x cubed over 3 factorial.
All right, I want one more. What? Oh, the one in the x do. Oh, sorry, I should have said 5 terms. I always get the terms and degrees, the words just slip up in my yeah. Apologies on that. I always mix those 2 words up because I always think like 4th degree is 4 terms, but it's definitely not. Yeah. Yeah, so I was just about to explain why I'm kind of stopping here. So here, what I'm trying to avoid is I'm trying to avoid having to go back and like fix things. So I'm giving myself a little bit of buffer room. I'm thinking first 3 non-zero terms. I may have a constant term, 1st degree term, 2nd degree, 3rd degree, 4th degree. That's 5. So I'm giving myself a little bit of room in case one of these terms or even 2 of these terms kind of cancels out in the process and becomes 0. So I'm banking on the fact that maybe going up to the 4th degree power is enough to handle any of the terms that might cancel. So cosine, I'm also going to take to the 4th degree. Thank you, Connor, for fixing my vocab there. So that will not be 4 terms. How does cosine start? 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. So again, I'm stopping here. You could go farther. I'm stopping here because I know it's a little bit more than what we need. I've done this problem before. But trying to be a little bit safe in case there is a term or 2 that goes to 0. I want to make sure I don't have to go back and fix everything. Yeah, so here I'm going to the same degree because eventually I'm going to be like combining like terms. So kind of trying to match what I've got. Yeah, exactly. All right, so I'm about to multiply these guys together. So when I do that, I'm gonna want numbers really, not just like factorials and unsimplified stuff. This we kind of do want to simplify. So I'm gonna write these again, but I'm gonna simplify those factorials. So this is now gonna be x squared over just 2. X cubed over what? 3 times 2 times 1 is 6. I should have given myself more room. And then x to the 4th. What is 4 factorial? Look at you multiplying by 4. All right, x squared over 2, x to the 4th over 24. Yep. So we're trying the plus dot dot dot, or in this case minus dot dot dot. I'm just trying to make sure I'm keeping my like equivalence here. I'm trying to make sure everything's still equal to the thing before it. So let's get some colors going. What's your favorite color? Blue. Which blue, Mason? Is that dark enough? Okay. All right. I'm going to start on the cosine side just because it has less terms. And I'm going to start distributing to everything. All right. This one, we're again building bravery. 1 times everything is just itself, right? So I'm just going to really copy this, and we're going to kind of align our like terms vertically. I found this to be the best organizational method. You can make your own if you want. But this I found helps me organize quite a bit. You'll understand what I'm saying in a second. All right. So we've got 5 terms here. What goes well with blue?
Purple.
Which purple? The dark one or the lighter one?
Lighter one.
The lighter one. Okay. So now I'm going to do the same thing, except I'm going to be taking this negative x squared over 2 through. So negative x squared over 2 times this 1 will be negative x squared over 2, right? So when I write that down, I'm going to align them so the like terms are kind of aligned vertically. I found this is the best way to organize. So I'm going to write that guy right here. All right. Then I'm going to take, I'm doing some pointing. Negative x squared over 2, and I'm going to multiply it by x. What will I get? Negative x cubed over 2. All right. Now I'm going to do negative x squared over 2, this one, times x squared over 2. So negative, let's see, that's x to the 4th over 2 times 2, that's 4, right? All right, looks like all of those are going to be minuses, so I'm writing minus dot dot dot. That's not a big deal though. All right, answer.
Why do we not go beyond?
Okay, so going back to, I was kind of talking to Connor about this. I want 3 non-zero terms, right? So it might be the case that I just have to do those 3. Looks like the x squared over 2s are not hanging around for very long though. So I was trying to think, if I go to here, the likelihood that I'm going to have a question where there's kind of more than 2 sets of terms canceling out, probably not that likely. So I'm guessing if I hit like 5 terms, so up to x to the 4th, I probably have enough to answer this question without having to go back. All right, let's, what are we distributing now? What goes good with blue and purple? Green, brown. I used to ask one class that, and they used to always say white, and it was like,
At least it's enough.
and then I like this green better. I'm choosing this time. All right, x to the 4th over 24. What am I multiplying that by? 1. Where am I going to put it?
At the very end.
At the very end. Now, do I have to worry about distributing that to more things? No, which is really exciting. So here we go. So let's talk about what we actually needed versus what we kind of have extra. So what will the first term of my answer be? 1. What will the second term of my answer be? X. So those didn't have to combine with anything. That's pretty exciting. Now, will I have an x squared term in my answer? No, these are canceling. So I'm excited that I went past the x squared stuff so that I don't have to go and readjust my entire problem. All right, will I have an x cubed term? Yeah. All right, I'm going to ask you the most difficult question I'll probably ask you today. What's 1/6 minus 1/2? I'm going to write negative a third, but that's fine. So you could leave it unsimplified. Ways you could write that term. Let's say you're just terrified of fractions on the AP test. Here's a way you could write it. If you're being really aggressive, yeah, anything mathematically equivalent is fine. I'm not cool with that, so I'm erasing it immediately. As long as it's mathematically equivalent, I'm fine. So I'm going to write minus x cubed over 3. Now, yeah. Do I have to go and do the x to the 4th terms? I don't want to add 24s together. Why don't I have to do more? It only asks for 3 terms. So this is my answer. Now, that's an aggressive problem. I believe there's one of these on your problem set, and there would be maximum 1 of these on your test. That's a very aggressive problem, but they will ask for a specific amount of terms. So I'm never going to ask you for the general term for this, because the way to find the general term would be to list enough terms that you can find a pattern. There's not like a fancy way to do the general term here. All right, you guys are troopers. Break time. All right, when we come back, though, we just multiplied.
No, don't make me smile.
Long division. All right, as it gets back to you, take 5. Can I what? Oh, my Glade plugin video. I bet that's gonna make my board just like, yeah. So the grade is going to be on next quarter, but we're going to take it before spring break because my teacher knowledge knows that if I teach you before spring break and test you after, those tests aren't going to look very good. Oh, there's a compilation? Oh, but my YouTube video is going to get like flagged. I don't want to play this. Look it up on your own. What? Oh, yeah. Oh. What? Is it small children singing?
Yeah, it's my mom's class. And then, do you remember Reading Rainbow?
Yes.
Yeah, and it's them, and they all just started singing it. It's adorable. She teaches 1st grade. It's so cute.
They're so small. So I will actually probably move it from this Friday, Monday to this, maybe not. Yeah, so right now it'll be Friday of next week. Yeah.
So like, I'm hoping to, if I like wasn't, that we could do the next
Yeah.
week as long as I can make them more. Okay.
A good day, if you have to take it after spring break, a good day. Oh, I didn't want to write on that.
Oh, is that Monday?
That Monday's a work day, so if you wanted to come in, and then we wouldn't have to do any like scheduling issues, that might be a good day.
Are you doing the classes?
The mock test. I'm trying to get a window. I know I have to attend a meeting that's kind of midday, so I'm trying to schedule around it. We're planning to do the Saturday, the 9th. I need to make that Google form. And then Monday, the 18th, I'm trying to get a different window. I might do like an afternoon window to counteract the Saturday morning. I think Miss Royce wanted to start at 9. 9 to you'll probably be done sometime in the like 12 to 1 o'clock-ish. If you're just gonna leave as soon as you finish what you can on the free response, then you'll probably be closer to 12.
guys are gonna break them?
Yeah, so I'll run the multiple choices through, and then the free response, we can either grade together, or any of the ones that are done that Saturday, I'll grade over spring break. No worries.
Dinner on Good Friday.
Yeah.
I didn't want to do it. It's like, it's nice to have another.
Yeah. And I'm going to try to make sure that Google form that I want to make, I'm going to try to make sure that there is an option. Like if you can't come either of those days, but you do want to do it, I'm going to either try to schedule like a couple blocks of time, or you could do like half and half. So you could come like maybe 2 afternoons after school or something, or 2 mornings, something like that. So trying to make it happen. Oh man, we are gonna have to do so much of 9.4 next time, and I don't want to. All right, you guys ready to long divide? All right, get your big person chosen bottoms on. All right, so would you agree? Tangent, sine divided by cosine.
Yeah.
Cool. What's our favorite? Hi, Gio. What's our favorite way to divide? Long division.
Oh, yeah.
I have a question.
Yeah.
Like, would you give us a question like this, like just where you have to like divide out? Would you tell us like sine or cosine, or would you just
Probably. Most of the ones I've seen, honestly, make you find like a function and then have you multiply by something you would know. I'll pull up for your response so you can see. All right. So again, we're gonna find the first 3 non-zero terms. So I'm just gonna go with 3 terms here, and I'm gonna hope that it works. Spoiler alert, it will. So, whoa. You can, yeah, usually 4 seems to be enough because the AP test is, they always give the first 4 non-zero terms in the general term. So 4 is usually like their magic number. I don't know why. Probably because 4 is like not super annoying. Small children. All right. Sine of x. What's he look like? X. See, you guys were worried when I said you would have to memorize these. And that's what I said. And you all were like, all right, cosine. How does that one start? All right, we can start. No. Brandon. Is there a reason for me putting plus or minus? Here, because I know the next term's minus, that's why I'm putting minus. Doesn't really matter because subtraction's just adding a negative number. So if you put plus, it wouldn't be. I'm just telling you 3 is going to work here. Division, it's not as hard to fix yourself later on because you can kind of just add the terms in a little bit easier. All right. Does anyone know which? Hello. Hi. Still doing stuff. What are you two both doing on your phones? This is absolutely thrilling. Oh, you can turn your desk if you want. Okay. Anyone know which one of these is going to go inside the division? Good. All right. So again, I'm going to simplify these fractions so that I have a little bit to work with. So I'm going to make this 6. Anyone know what 5 factorial is off the top of their head? 120. Perfect. 24 times 5. Because we've done it a couple times here. I'll leave this up now. All right. Here, I'm going to do 1 minus x squared over 2 factorial is 2. X to the 4th. 4 factorial, 24. All right. Let's see who remembers algebra 2. What goes there?
How many times 1 goes there?
It is x. And Bella gave a good description of what it was. What do we need to multiply 1 by to get x? The answer, x. All right. I am now going to distribute that x through those first 3 terms. I get x minus x cubed over 2 plus x to the 5th over 24. All right, I may do a little assist with the fractions on this one if you are okay with that. What do we do down, though? What operation? Subtraction. All right, will the x's go away? Yeah, they better. If they don't, you did it wrong. All right, I'm going to tell you, and you can confirm, negative 1/6 minus negative a half. That's negative 1/6 plus a half. We actually just did that math a second ago. That's 1/3. It's opposite signs of what we did before. So this is going to be x cubed over 3. Correct. Like terms, we want them to remain like terms. All right, what 2 fractions will we be subtracting next?
1 over 1.
All right, 1 1/20th minus 1 24th. Yeah, this is when you might have a calculator or a lot of time to think about it. I'm going to tell you this is x to the 5th over 30. You trust me? Cool. All right. I want you to think for about 10 seconds before you answer this question. What? What times 1 gets me x cubed over 3? All right, I'm going to make that positive. So positive x cubed over 3. Let us distribute. When everyone makes the same joke at once. All right. X cubed over 3 times negative x squared over 2. Oh, goodness. That is x to the 5th, so that makes me happy. And then 3 times 2, last time I checked, is 6. So I'm multiplying this by this to get that, this by this to get that. And I'm not doing this one because it looks like I'm gonna be cool and kosher. I would. It would be nice. Ma'am. Oh, yeah. So this for the first one. It's like you're distributing this guy into here. And then the x cubed over 3 would be the same thing. All right. Do the x cubed over 3's cancel? Yeah, they better. All right. What 2 fractions am I subtracting? Okay, I've got negative 1/30th, essentially plus 1/6. Calculator. 2x to the 5th over 15. And now I'm actually pretty excited because am I going to have to do this again? Am I going to have to distribute all this stuff again? No, I'm actually pretty much done because what times 1 gets me that? Yeah, it's exactly that. I don't have to check that by distributing through. I just know that is going to be my answer. So 2x to the 5th over 15. Did I answer the question? What was I supposed to do? I don't remember. I was supposed to divide. It's these up here. It's all the way back up here. Find the first 3 non-zero terms. Are those 3 non-zero terms? What does non-zero mean? Not zero. So yeah, we did it. Yeah. So yeah, so you're always focused on this first term for what to write down. 1 by to get this guy. And then what 1 by to get this guy. So it's always that first term. All right. Let's give ourselves a slight round of applause because those were hard questions. Way to go. Wow. What an enthusiastic round of applause. I'm feeling like we're a little tired. So I'm going to pass out a new round of notes. I know that you hate me and that's fine. They're much easier. We're not going to do a notes check today because we're going to save up our practice time for next time. Actually, what I'm going to do next time, I was doing it in my AB class, which was fun. I'm going to do a sticker problem set time. So you're going to work on your problem set, and every time you get a problem right, I'm going to give you a sticker. It was really fun. So I want to make sure we have a lot of practice time next time. So I would like to start the 9.4 notes. But before we do, I want to do another round because you guys did a really good job. I want to do another round of share out. So breakdown immediately. Find me something big or something small. Doesn't have to be big. Something out of 9.4 that you would like to share out to the class. Just from not 9.4, from 9.3.
Oh, emotionally, I will show you. What do you want to
Something you learned, something from 9.3.
I have it. That seems to be the trend.
That seems to be the trend.
You said it could be small, right?
Yeah.
Okay. Oh my
All right, are you guys ready? Does everyone? Oh, you guys are ready. All right, ready? Not ready? What? Because you're right in front of me. I can't see what's right in front of me. Yeah. All right, everyone stand up. Let's roll. Should I record our share out? All right, let's just talk it. What, Connor? Yes, Connor's group. You may go first. Okay, so when we subtract from a power series, we only subtract the one term. You guys can sit. Connor's group.
When we divide, we use long division.
When we divide, we use long division. Thank you. Nicole.
The series for each of the x, sine of x, and cosine of x are all true for all real numbers.
Oh, cool. Nice. They work interval of convergence everywhere. You guys can sit. James. No, Stan. Taylor series. Jill. Oh, okay, cool. So we could use derivatives to help us find Taylor series specifically for sine and cosine. Great, you can sit. Sydney.
Okay, so the absolute value of sine x plus the absolute value of cosine x.
Cool. We can add our series together and noticing some patterns, we could make e to the x from sine and cosine. Very cool. All right, we got 3 groups left. James. James, you're round 2. What do you got for me? Yeah. Yeah. Great reading. You may sit. All right. Tommy?
When you're multiplying or dividing.
Yeah.
Clarence series, you don't need to use the general.
Right. When we're multiplying or dividing, we're looking for a specific amount of terms. Don't really need a general term. What do you got? Oh, can you guys just remind me, what's the center of a Maclaurin series? 0. Thank you. You may sit. All right. So, to finish out class, I would like to attempt to get a little bit of this done. And by a little bit, I mean I want to end class a couple of minutes early because you guys have been working real hard. And I really appreciate you. I will say that. You guys have been doing a great job today.
Is this the last part?
What?
Is this the last part?
Of Unit 9? We have one more.
Okay, we do.
Yeah.
What is her problem?
Wednesday next week. Wait, no. I lied. Oh, I don't know. Hold that question. All right. What's our favorite type of series? Geometric. We haven't talked about geometric in a hot second. But geometric's a pretty cool type of series. What's one of the coolest things about it? We can get a sum, and it is kind of easy. So we're going to review a little bit of geometric to actually finish answering Michael's question from earlier of what are the series we have to have memorized. Geometric actually gives us the last one. It's probably not one you would think of to memorize, like a function that you think is really cool, but actually gets us a lot of things that we can do. No. So, well, we've been doing power series, right? Oh, yeah. So power series, yes. Power series. So that's why we didn't call it power series when it was a P series. So it's squares and rectangles. So a Taylor series is a type of power series. Oh, trying to tweak. That's all right. Yeah. So P series was like in our last chapter. It kind of stands for power, but we don't call it a power series because a power series like is this stuff. Yeah. All right. Oh no, this was the twos. All right. Are you ready?
Yes.
All right. So I'm gonna give you the first term and the ratio. You're going to help me write the series, the first 4 terms and the general term like we usually do. So what's the first term of this series? And it's labeled A.
2.
All right. You remember what the ratio is?
1/3.
Okay. So what's the next term of this series? 2/3. How did I get that? 2 times 1/3. So the ratio is what we multiply by every time. So this is the first term. Sorry, I kind of just jumped right in there. All right, now that we kind of have our bearings, is anyone brave enough to tell me the next term?
What's a third of 2/3?
Yeah, what's a third of 2/3? How do we multiply fractions?
I said cross. Wait, no. 6? No. Cross. 3 6. 1 time.
You guys just did infinitely long division. You can't multiply 2 fractions. Something has to go. All right. Multiplying fractions. Across the top, 2 times 1 is?
2.
If there's an equal sign in the middle. If you're solving. 3 times 3 is? 9. All right. All right. Next term.
4.
Nice. All right. We got our bearings now. 2 27s. All right. Do we remember how to write the general term of a geometric? When we looked for a geometric last test, what did we look for? Something to the n. What number do you think is going to the n power? 1/3, our ratio. What's missing?
And then plus.
All right. Now, is this a convergent geometric series? How do you know? Absolute value of r is less than 1. So we can find the sum of this, right? All right. What was that sum formula? Wow, aggressive. All right. Can someone tell me, one singular person, how to find the sum of this series? Okay, what's A? James?
A divided by 1 minus 1.
Okay.
2 divided by 1 minus 1/3.
Teamwork makes the dream work over there.
Let's go.
All right. Let's do the same thing. What's the only difference in the next question? Negative 1/3. So what's the first term here? What's the next term? What's the next term? Plus 2/9. Oh, I'm just wiling out with the 2's over here. All right. Yeah. What's the next term here?
Minus 227.
Okay. How would you rate the general term? You guys support each other so much. I love it. All right. What's going to change about our sum? Oh, yeah. So we got plus 1/3 on the bottom. All right. Now, a power series wouldn't be a power series if we didn't include some variables. So, well, who wants to do a series of numbers anymore? That's boring. Oh, okay. You guys want to take unit 8 again? Oh, I'm good. I'm good. Yeah. Still need to grade them, so that's good. All right. So let's instead pretend. Focus, focus. Are you ready?
Yes.
This is the important part. All right. I'm going to change. Now that we've got our bearings, I'm changing this to A is 1 and R is X. Okay? So what's the first term? What's the next term? Plus X. We're multiplying by X every time. So what's the next term? What's the next term? What's the general term? X to the end. Now, that's actually a pretty interesting polynomial, I would argue. Like 1 plus x squared plus x cubed. What would the sum look like? Cool. Now, so this is actually the last function that we're going to be able to build off of. You may be saying, why is that cool at all? We can actually transform a lot of functions to look similar to this. Does anyone know what these types of functions are called? You had a whole unit called this in Algebra 2. Someone said it. Rational. All right, so this is a rational function. If you forget that, what word do you see inside rational? Ratio, like a fraction. So these are rational functions. Let's real quick talk about, actually, how much time do I have? 45. All right, I want to try, I actually want to flip to the next page so I can show you this, because this is going to be the cool thing that we do with these. You're going to find it a little weird at first, so I want to show you one so you can kind of marinate on it before next time. No one likes the words I used today. I said in it to win it in this room in my Algebra 1 class because we were all staying in the room to take a quiz together. And one of the boys was just like, in it to win it. I was like, feel attacked. Yeah, freshman. You got to use some fun words sometimes. All right, I'm writing some directions that don't make any sense right now. If you could write them down, that would be great. All right, so it says change the center, make the 1, make the minus. Are you curious? Because I didn't want you to think it was an L.
Why would you think it was an L?
Just trust me for a second. Have I ever steered you wrong? All right, so what we're going to try to do while you're writing down those directions, I'm going to try to find a power series for 12 over 4 plus x centered at x equals 0. This one actually doesn't have a center issue, so we're going to skip step 1 here, but we're going to do steps 2 and 3 to try to make this look like this sum, because if I can do that, I can write it as a geometric series, which is pretty darn exciting. So what I'm going to try to do is I'm going to try to make this look like this sum. The things that need to look right are the 1 and the minus. If we had a different center, which we'll talk about next time, we would have to kind of make that x minus the center in parentheses. But here we're Maclaurin'd up. We got a center of 0. So what I'm going to do first, I'm going to write down this guy. I'm going to try to make this 1. Can you think of mathematical ways to make 4 into 1? All right, I could subtract, but right now my preference is going to be for divide. I don't want to subtract in this case, though we could in other cases, because I don't want to change the center. Right now I see x by itself. I like that. So I'm going to divide by 4, but I'm not really allowed to just divide by 4. What's the only thing I'm allowed to multiply by and not change things?
1.
Is that crazy, creepy fraction equal to 1? 2. Hate that for us. All right. All right. I'm distributing it in on the bottom, and I hate that x I just drew. Look how weird he is. Okay. Okay, we'll keep it. We'll keep it. We'll keep it. All right. What number goes on top of this fraction? You can multiply fractions. All right. So notice here we made the 1. All right. So that's what this step means. Now we're going to make the minus. So what I mean by that is I don't want this to be plus in the middle because our sum has a minus in the middle. How could I make that a minus? Oh, I don't want to multiply because I don't want to change the 1, but that's a good idea. How else could I try to make that plus into a minus? Oh, if I subtracted a negative number, that's the same thing as adding, right? You are fidgeting like crazy right now. Very distracting. No, it's fine. I'm just worried for you. Are you okay? No?
I think it's for
Math overload. We're done. We have been doing this for a while. We got 1 minus negative x over 4. So all we're going to do right now, we're going to find what a and r are. We're going to write the first 4 terms in the general term. All right. Remember, our sum is a over 1 minus r. What's a? Say it prouder. 3. All right. Look at where r is. So see how a over 1 minus r, the 3 is where the a is. All right. Who thinks they know what r is? Good. All right. Are you ready? The last thing we're going to do, I promise. I've been lying a lot today. It's not been good. What's the first term? Good. What's the next term? How did I get that? I multiplied by negative x over 4, the common ratio. What's the next term? Plus or minus? Good. 2 more terms. Plus or minus? 64. All right. General term, even easier. What goes in the n power? What goes in front of the parentheses? 3. All right, so we're going to practice more with this next time. What I need from you, actually, before even what I need from you, I would like to apologize for how much I talked today. That was a lot. Your brain's probably mush. Thank you for paying attention and participating. I very much appreciate it. We're going to finish out these notes next time. I'm going to see if there's anything I can cut out of it to make it as short as humanly possible. What are you going to bring with you next time? Problem set. We doing sticker problem set time next time. Liza, I need to look at my due dates. No, the problem set will be due no earlier than Friday. Like tomorrow, I'm not even going to see you guys. All right, no earlier than next Friday. I will come with a full schedule of dates next time. Problem sets up here if you still need one. Thank you for your hard work. I will come with scheduled dates next time.
You guys are really smart.
Yeah. You are. You answered so many questions today.
Well, I can't even pretend, so I understand.
Anyone problems? Thank you. Thank you. Hold, please. Oh, next block? Yeah. Do you want me to just give it to you?